Okay, good evening, everybody. The topic of today's talk is the synergy pathway to carbon neutrality and the clean air, especially for China case. So as we all know, we have globally we have the challenges for the climate change. So in that case, especially in 2015, the Paris Agreement has been takes the long-term goal to control the temperature, rising not to exceed 1.5 degree. So that we're trying to achieve the net zero emission from 2045 and to 2060. So China has announced our objective last year, which is we have to achieve the carbon peak before or by 2030, and also the carbon neutrality by 2060. So I think most of you is learn about that already. So actually in China, it's not only China, but also most of the developing countries in the world, we still have not only the problem for the climate challenges, and also we have the current environmental issue, especially for the air pollution, for most of the developing world. So for China, actually we have the air pollution control has achieving remarkable results for the last 10 years. And the concentration, for example, the PM2.5 has been dropped significantly, not for the last 10 years, not the one decade. But there is still a long way to go, or we should say a large gap between the current PM2.5 concentration and the WHO guideline value for PM2.5. So the problem, on the other hand, the problem of ozone problem, that is another kind of air pollutants, is becoming increasing. So that's it's a new challenge. So in that case, we have to deal with not only the climate issue, especially carbon emission reduction, and also we have to deal with the problem for the air pollution. So that is not only for China, again, it's for most of the developing world, of developing country in the world. And also for some of the, even the developed country, for example, the ozone problem. So actually, we should find there is the significant synergy of carbon reduction and pollution control measures. So if you look at these two graphs, this is a CO2 emission, the historical emissions from 1990 to 2020. This is for carbon, this is a China case, carbon dioxide emission, CO2 emission, and this is the current air pollutants is a NOx emission. You can see the secondary contribution is quite similar, which means it comes from the power plants, industrial and transportation, and also residential sector. Both of them is for CO2 and NOx. It's quite similar. So a lot of research in the world, international research, international study results showing if you deal with a carbon emission reduction, they have a very large potential benefit for the air pollutants. And for China case, that is the evaluation for China's national air pollution control planning, and you can find a lot of benefits for the carbon reduction along with such kind of action plan. So for in the future for China, I just mentioned, for PM 2.5, we have remarkable achievements already, but it still has now the problem compared to the WHO guideline. Even some of the Chinese cities, almost 1/3 of Chinese cities, still cannot meet the national standards, the current national standard in China. And also we have ozone problem. So if you're thinking about the future accelerating the aging population that is already coming to China, the aging population will be increased. That is the important trend. So we have a very concern in the future for the better environment quality, especially better air quality, will have a large benefit for Chinese people, especially for the future aging, the coming aging population. So, so in that case, we should see globally we have a climate objective, especially carbon neutrality. In China, we have we call it a beautiful China objective, especially for air quality. We need the better air quality. So carbon neutrality and better air quality. Actually, they have a very strong, the carbon neutrality target is highly constant with the clean air goals, especially in China. So if you look at we just mentioned our carbon peak by 2013, carbon neutrality by 2016, and also for the air quality or environment goal, we just see by the middle of this century, the eco progress will become comprehensively improved. So that we have, it's including the blue sky or better air quality in the future. So in that case, the Minister of Ecology and Environment of China put forward to promote the synergy between carbon neutrality and clean air. So they have to put the transmission of the end of pipe control to source treatments, and then finally fundamentally solve the pollution issues by climate adaptation and also the carbon reduction. So that is the action planning in the future. So first, let us to see what happened for China or for the last 10 years or for the air pollution, and also the changes in the weather and also the climate conditions. So we can see the first for China, the PM 2.5 concentration has been dropped significantly, but the problem is still serious, I just mentioned before. But here we have some data or graph. These two graphs, the blue one is annual average for China, but it's in different, that is a nationwide and also the different region. But the trend is even for the very heavy pollutants region, they still have very large improvements for all of the regions. This is a current national standard. And also we have another data for the yellow graph. So this is a 3-year moving average concentration, but it still has a very clear decreasing for the concentration for PM 2.5. So they have seen the population compared to the health impact assessments, the population weight average pollution PM 2.5 concentration in 2020 was 33 microgram per cubic meter. So that is close to the average value is already meets the national standard. So even for the 3-year moving average, is still decreased very obviously. But the problem is for the ozone concentration, it has become the increasing problem. So again, the blue one, the blue graph is the annual average. So you can see all of the different region or national average or the region average in different region of China is going up, it's increasing. But it also it's a similar trend for 3 years moving average for ozone problem. So we have, which means for PM 2.5, we have achievements already, but the problem, we still have a long way to go. But for ozone problem, it's increasing. So that's a new common problem. We'll have to deal with that in the future. So that's a problem for the true, the typical air pollutants. This it's a top two, PM 2.5 and ozone. But if you look at the air quality or air pollution, it's very close relations with the meteorological condition or weather condition. So you can see in the eastern China, from the last 5 years, the weather condition is generally favorable for the PM 2.5 pollution. So for example, in Beijing, Tianjin, and the Hebei region, we often see it's a Jing-Jin-Ji region. It's a Beijing and surrounding area. The average relative humidity was about 16 during the last 5 years. And the relative humidity was significantly higher in last year, 2020, than that in 2019. So, you know, the weather condition will have a very heavy impact on the air quality. So in the Pearl River Delta, the average relative humidity was about the 80%. In the Sichuan Basin, we call it the Chengdu and Chongqing region, that is southwest China. The average relative humidity for the last 5 years is still very high, it's about 80%. So that is, which means they have a strong push for the pollutions. And also they have, because of the climate issue, we have feeling more and more extreme weather events. 2020 actually is also happening in this year. So on the climate scale, the average surface air temperature of China in 2020 was 0.7 degree higher than the climate mean. Here we call the climate mean is the average volume reference to the year 1981 to 2010. So that is a long-term average. So you can see we have the very strong the relationship between the climate change and the changes in meteorological elements and also the air pollution. So they have a two-way impact. So for example, in 2020, the topical sea temperature in the central and eastern Pacific will be abnormally lower. So the La Nina phenomenon may appear. So in that case, which will causing the deterioration of the atmospheric diffusion conditions in winter, especially for southern China. So they have a very strong phenomenon in the two-way influence. So that is the basic information for the last 5 to 10 years. What happened for the air quality? Even we have the mandate or the very strong efforts for the control the air pollution emission, but we still have the problem there, and especially they have a strong impact between the air pollution and the weather condition. And also the weather condition has a strong links with the climate. So that is very important. So, and then here we have to see we should pay more attention to the synergistic reduction of greenhouse gases and air pollution, because they have strong two-way impact. So that we just see we were very concerned about the synergistic reduction of these two greenhouse gases, especially carbon dioxide and also the air pollutants. So if you look at in China, actually we have made very strong efforts trying to improve our energy structure, industrial structure, transportation structure, to reduce the current air pollutants, and also has a very strong benefits for carbon reduction. Here is some information. For the energy transitions, here is information for China 2000 to for the last 20 years, 2000 to 2020, so almost for the population, GDP, and also the total primary energy consumption. So it's, but say the energy is, total consumption of energy is increased, but if you look at the blue graph, that is the first one is a proportion of coal consumption. The coal consumption is getting lower. That is a proportion. So it's from more than 75% to less than 16%, 60%. That means it's almost as 55%. So, but they have some increase of the oil consumption and the natural gas consumption and the renewable energy. Gas and renewable energy is getting increasing. So if you look at the last 7 years, 8 years from 2013 to 2020, we have done a lot of working, but in order to improve the air quality, but they have a strong push the improvement of improve the energy structure. So here we have some effects. For example, we have more than 300,000 small coal-fired boilers was eliminated nationwide. So more than 300,000 small boiler has been phasing out. And second one is a coal-fired boiler less than 35 per ton vapor per hour in key area was basically eliminated. So that, which means the small or a little bit middle scale boilers has been phasing out. And the third effect is natural gas. For the natural gas consumption increasing by 116 billion cubic meters nationwide, and we have 26 million households change the bulk coal usage to electricity for heating. So this is a very strong transition, and the clean heating in rural area already starting explored already. So in that case, we have done a lot of working. Here we have some information for the industrial structure. It's improve the industrial structure. Here you can see they have the installed power. This is a power sector, power capacity. As a cool. The second one is a crude steel production and the cement industry. So all of them is increasing in total. But if you look at the structure of the primary industrial, secondary industrial, and also the tertiary industrial, the primary is getting down and the tertiary increase. So which means we have, and also the secondary is still a little bit lower in the decrease. So what happened? Why we can achieve that? So I think there is three important information. One is a new industrial and the new business model was growing rapidly. And the second one is clean, because of the clean air initiative, that has pushed the acceleration of the elements of backward production capacity. So there is some information here. I don't want to go to detail for every the figures or data. And the third one is phasing out the poor manager and the polluting small enterprise. So they have has been for the last 8 years about 616,000 poor manager or pollutant small scale enterprise will eliminate. So let's look at something for the transportation sector. So they still has adjustments. So the transportation sector, we have the, for China, the car ownership is going up. Today, China is the largest car market in the world. So, but we have the new energy vehicle ownership is getting very high, and also we have using the new emission standards, renew the emission standards. So, which means now we have using the national 6 emission standards is almost equal to Euro 6 emission standards, and also you need to improve your fuel quality, and especially for the new energy vehicles, especially for the electrical car. Also, that is the largest population in the world for China. So, a story about the small words, but it's just the summary. We have done a lot of working here for the end of pipe control, for example, the ultra low emission control for the coal-fired power plants, and also for some of the steel industrial, and also for VOC control for petrol industrial or chemical industrial, and also a lot of working for the clean heating in rural area and for car emission control and so on. So in that case, we have, so you have done a lot of working. What is the result? The result is we call carbon peak, but actually for other air pollution emissions, we have a peak already here. So SO2 peak, emission peak has been happening in 2005, and NOx emission peak is 2012, and also recently we almost reached the VOC and ammonia national the emission peak. So because of so many control measures, so we have getting a better result here. So if you have done the emission, the reduction of the emissions in the from the ground, and then you will get a better concentration in the air. So here we have, you can see this is a PM 2.5 concentration annual average from the last 20 years. So you can see after 2013, all of them, different regions of China is getting lower. So the PM 2.5 concentration will have really getting a lot of achievements. So if you have such kind of achievements, and then you have better benefits not only we see is the visibility, but also especially for the health. So you have the health benefits from clean air action of China. So here is for the long-term, short-term, the exposure level annually for China is really improved. You can see this is the peak concentration is getting lower for long-term exposure and short-term exposure. For short-term exposure, which means the very heavy the concentration, a very higher concentration of heavy pollutants case. So in that case, we can get in, here is a changes of per mature days attributable to PM2.5 long-term exposure during the last 8 years. So which means that compare with 2013, the premature days attributable to PM2.5 long-term exposure reduced by 200,000 people. So it's about 14% decreasing in 2017. So let's look at the short term. So what happened for short term? So because of the remarkable reduction of the heavy polluted days, so for the very higher concentration, the days with a very higher concentration, this number of these days is decreased very rapidly. So because of the remarkable reduction of the heavy polluted days, the premature days attributable to PM2.5 short-term exposure decreased by 61%. So that is some of the studying for the environmental health experts. So that is really a very important the achievements from the Blue Sky or Clean Air Action Plan. So here is the counting level days attributable to PM2.5 for long-term and short-term. So you can see which area in China, which area or which city is getting more benefits from the Blue Sky Action Plan. So we also have, you can see which area, and also somebody asked, so which kind of control measure contributes more to the health benefits? So here we have some results. If you look at this, the pie chart, and you can see the blue one is strengthening industrial emission standards, and the dark green one is upgrades the industrial boiler. So that is the top two. And number three is phasing, the light blue one is phasing out the outdated industrial capacity. And the pink is the promote clean fuel in residential sector. So that most of them is a coordinated action plan that is getting the more benefits directed for the health impact. So, and also for that, we can get in a very detailed information for the core benefits. I just tell you the CO2 emission. So at the very beginning, you are focused on the blue sky or air quality or the clean air action plan. But if you want to do that, you have to do something for energy structure, industrial structure, and also the transportation sector. So in that case, you have some, even this is not a positive reduction, but it's still reduction there for CO2. So here we can see they have some reductions, and also for the CO2 reduction compared to the baseline, especially for the last 8 years for the Blue Sky Action Plan. So the number one contributor to CO2 emission is phasing out the outdated industrial capacity. And the second one is the upgrade on the industrial boiler. So just remember, both for CO2 reduction and also the health benefits, this is quite similar sector contribution. Here you can show this graph and also the graph. So I think that is really helping. It's very important. And also we have doing the effect of synergistic emission reduction of CO2 and air pollutants. You can see here we have, this one is a CO2, and also we have power sector, heating sector, industrial, residential, and transportation. So you can, and then there's a CO2, SO2, NOx, PM2.5, and VOC. So you can see for power sector, all of the Blue Sky Action Plan has getting the reduction of the current air pollutants, but it's because of the capacity increase, so the CO2 is still increase. But for the industrial, for all of them, it's not only for air pollutants reduction, but also we have getting some CO2 reduction. So why? Because we have done, because of the important things is this for elimination of a small coal boiler, coal-fire boiler, and shut down the outdated production facility, and also the clean heating in rural area, especially in northern China, and also the restructuring of the transportation. So most of them has not only the reduction of CO2, the current air pollutants, but also have the reduction for CO2. But for power sector, most of them is using the ultra lower emission standards, end of pipe control. So you have to, it's not the benefits, big benefits for the CO2 reduction. So that is a difference. So for recently, in recent year, for China, the growth rate. So you can see CO2 is a still increase, but the growth rates, so the average is growth rates for the anthropogenic CO2 emissions has slowly down significantly. So here we have some number. As the average annual growth rates of emission from 2013 to 2020 is about 1%. So growth rates is 1%. So which is much lower than this number for 2002 to 2013. So this number is almost 10%. That is 9.6%. So from 10%, almost 10% to 1%. So actually, I think I'm sure the Blue Sky Action Plan has the very strong positive push for we can achieve such kind of synergistic reduction. So if you look at all of the Chinese middle-scale Chinese city, totally we have 337 Chinese city. So among them, 98 cities already achieve synergistic emission reduction in the annual concentration, which means these 98 cities, both PM2.5 concentration and the total CO2 emission is getting down. But they have more than 200 cities, it's a PM2.5 getting down, but CO2 is getting still increase. And also they have less than 10 cities, that is a very bad news, is PM2.5 is a still increase, and also CO2 increase. So that is a very challenge for the mayor of such kind of cities in the future. So we're just getting some information for you about what happened for China trying to get blue sky and also the benefits for the greenhouse gases reduction, especially for CO2. But actually, we are researchers. We are not just summarizing the literature review for them, for what happened for the different regions for CO2 and PM 2.5. Actually, the first one we need to set up, if want to, we hope we will realize our goal for both the carbon neutrality and also the blue sky. So we have to develop the research tool, and also we have to generate the database to support us to do such kind of research. Actually, today we have in the world, a lot of researchers has done a lot of working supporting us to do such kind of research. How can we get the better synergistic reduction in the future for both the carbon reduction and the air pollution control? So first, here I just want to see developing model and database on the integrated assessment of carbon neutrality and the clean air. The first one I want to see the atmospheric emission models and database. Why? Because everything for the climate issues in the air pollution in the air, but the basic reason, the basic source comes from ground, so emission. So everything comes from emission. So the solution is in the ground, is underground. So if you understand better for the emissions, and then you can have the better position to trying to find the better solutions in the future. So here, I just show you the emission model and the database. Domestically in China, we have a lot of research people to do. For example, in Tsinghua University, we have to make the multi-resolution emission inventory for China. They have more than 500 users in the world today. And second one is a carbon emission accounting and database. It's also generated by the Tsinghua professors. And the third one is the Peking University, the studying achievements, which is a global emission inventory. And also we have done they're working for global energy infrastructure emission database and carbon monitor, something like that. For the internationally, so you know they have IPCC has used a long history the INDICA database, and also the other database has very popular in the world. And here has a few more words for the Tsinghua model, make model. Now this model has been developed and maintained by Tsinghua University since 2010. So that is a design to establish the high resolution anthropogenic air pollutants and carbon dioxide emissions. So here we have getting that has been used that for the scientific community, and also which can benefit for scientific research and also the policy assessments and also the air quality management. For the second one, the carbon emission accounting and database, it is developed by Professor Guan Dabo and Professor Liu Zhu in Tsinghua University. So they also has covering China and other emerging economies. So it provides the carbon emission information. And I think recently just released one report. You can keep making reference for that. PKU Global Emission Inventory, we can find that is developed by the team of Professor Tao Su in Peking University. That is also the global coverage, long time series, atmospheric components. Its detailed emission sector has, and also a high spatial resolution. It's a 0.1 degree globally. So that is quite useful. This is also the new database. This global infrastructure emission database that is developed by Tsinghua team. As we're still working on that. That is containing global infrastructure level information and also emissions. Again, it's also 0.1 degree. It's a high, it's very high spatial resolution. Could be used in the carbon grade. That is also very useful for that. So another one is application. Here a few more words of the application of the global infrastructure emission database. So this is we can using that. Here we have already have some publications here there, and we can find the small fraction of power units. It's a super potent power units will identified commit to larger fraction of total air pollution emitters. So which means if you have such kind of database, and you can searching so-called the super emitters in the world. So they have here we have to show some in China, also in India, or in United States, or in Europe. So that is the plant-based information, very important. And also for the CO2, it's also we can get in, the very important results is strategic early retirements will have benefits, can bring the significant cumulative air pollution improvements and also the health benefits. So if you have the detailed information, the database for that. And also we have the energy system. So energy system and the integrated assessment model. I think the energy model experts is very familiar with that. So for domestically for China is like the Energy Research Institute, the IPEC model, and also C3IAM model is the Beijing Institute of Technology, and also IMET from Peking University. Internationally, you have a lot of famous models like the MESSAGE and GCAM and IMAGE and AIM. So they have a lot of for the integrated model. I think it's very active for such kind of model today. For future emission scenario, that is also very important tool to design. So here we have a scenario MIP for CMI IP6 and the GINS from YASA and DeepPEG. This is a recent development by Tsinghua University, DeepPEG. So in some international or domestically, we have some kind of, the future emission scenarios is also very important for us, to design. Before we have a lot of international working for China, but it's not all of them is quite right for all of the items. So we have to do, even for the IPCC report, we need more working to improve that in the future. So here is the DeepPEG dynamic projection model for emissions in China. So we have designed already DeepPEG V version 1.0 and version 1.1 is already. Some of them, they have some publications. You can make a reference for that. We have multi-source monitoring and retrieval of atmosphere. You have a database for emissions, and also you have a model for projection. And how can we get in, we call it the variation or the verified. How can do the verification of your results? So we need the information from the monitoring system. So here we have the monitoring system for ground measurements and the satellite retrieval. And also have a between that we have a model the simulation. So they have the integration of them. So that is also the new database from Tsinghua University. Is already open for globally. We call it Taking Air Pollution in China, TAP. So they have developed by Tsinghua and provides the daily near real-time data production through the cloud computing and big data management, which have integrated the ground monitoring information and satellite information, and also the emission plus model simulation system. So that is an integration results. So for the carbon monitor network, we have globally they have a lot of measures like with a multiple platform and resolution, global, regional, and city level. Here has some the carbon monitoring system, but it's most of them is still improved or under construction. I think in the future will be getting better. The carbon satellites remote sensor observation. Here we have some of them. This is the black one is international, but in China we have one that is set up by Chinese Academy of Science. That is a carbon satellites that is already working. That provides the data for us. So everybody see big data, but first you have getting data. So you have to getting data from some way. So we have in China we have some, and also you have the simulation model for carbon source and sink. So they have a carbon monitor and also the global regional retrieval of the carbon source and sink. So this is very active in the world, still helps very helpful for us to the future projection working system. So here we have a summary for the retrieval data products for carbon source and carbon sink. This area is international and also have a lot for the domestic production. So if you want to do some working, and then you can find from this table. And finally, there is another modern tool that is an integrated cost-benefit assessment assessing model. Here we have several. For example, the Abacus developed by Tsinghua University, an image from the Peking University, and GAINS from YASA in Austria. So that is, they have put the, you have the control options, but also you have the considering the cost benefits. So the cost of different control options. So totally they can integrate the cost benefits analysis for such kind of model. So any action plan, we cannot forget cost. You have to very concern the total cost. So this is an example for that developed by Tsinghua, and so it's almost more than 15 years. So every year we have annual. Actually, it's a co-generation by Tsinghua University and EPA United States. environmental protection agency of United States. So we are working together for more than 15 years. And every year we have Abacus annual workshop or annual conference. So this year is planned to do that in middle of November, middle of this month in Chengdu, because now it's impossible, and maybe the beginning of December, still in Chengdu. If you are interested, you can come to Chengdu to attend this kind of workshop. So here is some of the model and some of the database. Remember, if you want to do some research, you have to learn more the research tool like model and research source like the database. And then you can do some work and show some people, see, I have to do something related to big data or something like that, or machine learning or something like that. But you have to data is important. So the last point is just show you one example. How can we use this model to do the carbon neutrality and clean air assessing? That is the platform. You have remember I showing some of the tool or database, but frequently I've mentioned here we have an example for Tsinghua, another example for Tsinghua, and then we have now we have the platform, Tsinghua related model, or actually we say it's a Tsinghua leading model, but contributors, not only researchers from Tsinghua, it's from globally. But we have established the new platform. We call it a carbon neutrality and clean air assessing platform, CNCAP, the CNCAP. So yeah, they have included the scenario design, emissions, air pollutions, and cost benefits. So I don't have time to go detail and what is the different components of this platform, but you have included many of the models I've mentioned before, and also the database I mentioned before. So we can use this platform to do the historic analysis and the future projection. So historic ones here is, for example, last 13 years. What happened for China for CO2 emission and the major air pollutants. And also you can divide it into the different by fuel type and also different by sectors. So this is the information. And also this database, they can provide the facility level CO2 and air pollutants emission of China for the industrial sector. For example, here we have a different kind of, including the power and the iron and steel and the glass and cement or something like that. So it's very detailed. And also you can get in the historic synergistic variation of CO2 and air pollutants emission. You can think as that. On the right is SO2, and the left is CO2 for the last 20 years. So you can see the CO2 is still increasing, but the SO2 after 2005 is getting down gradually. So they have it's only for power plants. We have a similar result for based on the GID. We have shown a lot of results not only for China but also the other region of the world. Here is a 0.5 degree resolution for last 13 years, the great CO2 emission. So they can support it for carbon cycle simulation. Monthly CO2 emission for 0.25 degree resolution. This is an example for residential sector. That is a great CO2 emission with a 1 kilometer resolution for whole China. The air pollution emission for 3 kilometer grade resolution. That is just an example of SO2, and within the database you could have a NOx, you could have a PM 2.5 and VOC, ammonium, and so on. So this is from the TAP database. So they can show the PM 2.5, the time series, and also the spatial evaluation. So it is very clearly showing the PM 2.5 in China has been increased since 2000 and gradually decreased after the 2013. So and then it's getting better, and so getting worse, and then it's getting better. So that comes from not only the ground measurements, but also the satellites retrieval and also the modeling emissions. So, and then they can get in, very detailed information of the drivers of China's PM 2.5 pollution associated with the per mature days. So they can, so what kind of, so here in general, we can see because of the economy growth and also the aging population, so that is an increase in the per mature days because they have increased the emission. But for the climate and energy policy and also the end of pipe control pollutants, that is decrease the per mature days. So they have a different, very details of different kind of driving factors. So for the future, that is the historical analysis. If you have trying to do the future projection, we have doing until 2016. Here we have for 4 sectors: power, industrial, residential, and transportation, and five scenarios. Reference NDC, 2 degree carbon neutrality, and 1.5 degree. So they have shown a different structure for a very strong push to the improvements of the structure of power, energy, and residential and transportation. So I don't have time to go to detail. And also they can show if you want to follow, for example, the 1.5 scenario or the carbon neutrality for the scenario. And then what happened for China's power sector, especially the retirement pathway of the thermal power plants. That is very important for China. Of course, this is just the one example for our research. But this platform can provide a very useful tool for the discussion or even the debate or arguments for such kind of question. I mean, the retirement pathway of thermal power plants up to 2016. That is very important for China for future carbon neutrality and also the air quality. So we can show China's future emission pathway under the carbon peak and also the carbon neutrality targets. So here we have the results for the different baseline NDC, 2 degrees, 1.5 degree, and also the carbon neutrality. So carbon neutrality is something between 2 degree and 1.5 degree. So this is a CO2. And what happened for the other pollutants, SO2, NOx, and PM 2.5? By using such kind of a platform, you can get in very clear the future pathway. Again, the scenario is designed by different researchers, but this platform can get in very important platform, for the discussion. So if you have a different idea for the future pathway, and we can put the different scenarios and then discussing what is a future problem. So, but they have a very good news for air quality. I just want to show here we have doing sum up. If you follow, if without carbon peak or carbon neutrality targets, and the air pollution will be the air pollutants reduction potential will almost phasing out or over after 2030, which means the end of pipe we do not have any more potential for future reduction. But if you're following carbon neutrality, and then you have very large emission reduction potential, which means they were getting us to the WHO the very lower until 2016, very lower PM2.5 concentration. It's less than 10. So that is the WHO the guideline before this September. So, and also we have a very good exposure level, which means we have very large the potential for the health benefits, which means your annual average for whole China nationwide of PM2.5 will reduce to almost 8 microgram per cubic meter. Today is 33, and in 2016, if you follow the carbon neutrality pathway, and then you can getting 8 microgram per cubic meter. That is really good news for Chinese people and also for the people in the world. So, but the difficult part is the energy structure. So if you want to realize that goal, I mean the better air quality, like the less than 10 PM2.5 to the concentration of PM2.5, 75 to 80% will rely on the energy sector. So that is a huge the task for in the future for the energy sectors. So that is a basic result. Okay, so here is a summary for the results, which means that if we just doing, this is a baseline, this is 13.3 for PM2.5, and then this is if you do nothing, and then you have going, this is a baseline until 2016, is still 13.3. But if you have following the end of pipe or the only pollution control policy, finally we can doing the largest potential, will reduce the PM2.5 to 25. But if you have a carbon peak 2030, and then this number will be 20. And if you have an early carbon peak, for example, 2028, and the PM2.5 will be 18. But if you reach carbon neutrality in this 2016, and then your PM2.5 will less than 10, it's something like say 8.5 microgram per cubic meter. So that is really the very strong synergistic pathway so in the future. So this is the last slide for my presentation here, which means that everybody see you have shown a very beautiful picture. If you have the carbon neutrality, and then we will have a very nice the air quality. So, but how can we reach the carbon neutrality? So the pathway. So here, that is not the major objective for my presentation. For this lecture series, the following a number of the professors will answer this question. But here I just want to show we have to doing the carbon reduction by reducing the utilization or the energy saving, energy efficiency, or something like that. And second one is a carbon reduction by adjusting energy structure. And the third one is this decarbonization for industrial process. And the third one is a CCUS, with a carbon storage, carbon capture and utilization and storage. And the last one is an ecosystem carbon sequence, carbon sink. But that is 5 kind of technology options. But remember, any technology, you have to thinking about the cost. So we have to using the carbon reduction by using the market mechanism. So I think maybe Professor Zhang already given some of the information for the carbon mechanism. So for my, in conclusion, my presentation, so I want to emphasize on we should fully consider the synergistic effects of a different technological paths for air pollution emission reduction. The second one, we should promote the improvement of the air quality as an important constraint for the choice of carbon neutrality technology pathway. And the last one is trying to maximum the synergistic effects of reducing pollution and the carbon emissions. So I think that's all for my presentation today. Thank you very much. So we have